Here is one of our first geometry proofs, and on this proof there are a couple of edits that we need. 4 and 5 lines here are exactly the same, and this line should say measure of 1 plus measure of 1 equals the measure of ABC there. And we're going to need to add a line 7. So I'll help you fill that in, and I'll explain why we're adding that as we go. So up here they have a vocabulary word in the given. Know that usually that's going to be having a definition in one of our reasons if we've got vocabulary for a given, or sometimes it's property of that vocabulary term, just depends on what it is. They're saying that BD bisects angle ABC, and we know that when an angle is bisected, that these two angles will be congruent. So the first thing here, that BD bisects ABC, that was given to us, that's given. It's like a free answer, but again, remember, prove is never a reason, don't put that. So this angle is bisected, and you can see definition angle bisector is the next reason. The definition of the angle bisector tells us that angle 1 is congruent to angle 2 by that definition of angle bisector. Now, since we have in this proof statement, we have an equal sign, we have 2 times the measure of 1, we know that we're going to do some math with these angles 1 and angle 2. Since we want to do math with them, we need it to not be the congruent symbol anymore. We need it to be the equal sign. So we're going to go from congruent symbol here to saying that their measures are equal to each other, because we want to do math with these particular angles. So anytime you're wanting to do angle addition or segment addition or anything like that, you're going to go from congruent to equals. And anytime you go from congruent to equals, it's just the definition of congruent and then whatever the item was that you're talking about, and in this case they were angles. And you can abbreviate that. I usually put DEFN congruent angles. So that means the same thing as what they have written out. So that's, you can abbreviate if you want to. Now, we are wanting to talk about the measure of ABC. The measure of ABC is putting these angles together. And so if we're wanting to do that, we're wanting to add these angles equal to the whole angle. And when you're doing that, that is angle addition postulate. Adding 2 angles equal to 1 large angle that they create, angle addition postulate. So that is what line 4, that's where that's coming from. They're adding the 2 equal to making that whole angle there. Now that we have that written out and we know that 1 is equal to angle 2, we can replace this measure of angle 2 with the measure of angle 1 below there, and it should have said the measure of angle 1 there. And that's substitution property of equality, and they filled that whole thing out for us. Now, how we want it to look was we wanted it to be 2 times angle 1. So if we're combining these angle 1s together, they have decided that this is distributing them because there's 2 of them. And so instead of having measure of 1 plus measure of 1, writing them as 2 times the measure of 1 is kind of like distributing, or really reverse distributing. And honestly, if you put, instead of distribution here, if you put combine like terms or even simplification there, I really feel like that would be acceptable. So 2 times the measure of angle 1 equals the measure of angle ABC, just really combining like terms there. And now the reason I had us add a line is if you look at where we're at, these angle 1s, they were on the left side and the measure of angle ABC was on the right side. And our prove statement, what we want to prove, has the measure of ABC on the left side and 2 times the measure of angle 1 on the right side. So we are having to switch sides here. The measure of angle ABC equals 2 times the measure of angle 1. And so that's symmetric property, and in this case it's an equal sign, so of equality there. for that reason. Now, had we thought about it in step number 4, if we had realized that we wanted measure of ABC on the left side, we might have started with the measure of ABC and then said equals to the measure of 1 plus the measure of 2 on the right side, and then we would not have had to do that extra step on line 7. So sometimes if you think ahead about how you want the order of it to look, it could save you a step in the long run. Our last proof here is about segments. It says given AB is equal to CD, and they've got those marked in the picture for us. Our goal is to prove that AC is equal to BD, really by adding in this segment BC that is in the middle there. So the first line, that's our given. And the second line, I kind of think about, is this coming from the line above? No. Look at the picture and see where that's coming from. They're saying that AC equals AB plus BC. AB plus BC, they make AC. They're adding the two segments to make the big segment. That is segment addition postulate. So just abbreviating a little bit there, segment addition postulate. Adding two small segments to say that they make a bigger segment, segment addition postulate. It's different from just addition because you're saying, the one is made up of those two items. BD is created by BC and CD, and that's what they've got going on here, and that's also segment addition postulate. This is how I usually abbreviate that, seg add post, segment addition postulate. Now, before this line, I kind of feel like we need an extra line here, and so I'm going to add that in. Before I'm adding BC, I kind of feel like I need to say that BC is equal to BC before I add it to both sides, which is what they're doing. They're taking this first line. The way that they're getting this line is that they're taking this line of AB and CD and they're adding BC to both sides. And since they're going to do that, I should clarify that BC is equal to itself before I start adding with it. And so since it's equal sign, it's reflexive property of equality there. And then we can add it to both sides. So this is not segment addition because we are not renaming. We are adding the same thing to both sides of a statement that we already had, which was right there at the beginning, just adding BC to both sides. So this is just normal addition. So addition property of equality, if you want to have that on the end there. So they're adding the same thing to both sides. Now, the way we're getting from this step to the final step, I'm going to do some highlighting here. I want to show you we have AC here and AC here, and AC is equal to AB plus BC. So where it says AB plus BC, we're able to replace that. We're able to replace that with AC. And where they have BD, well, we know that BD is equal to BC plus CD, and so BC plus CD is right here. Essentially, that's the same expression as that one. And so we're able to replace that with BD. Now, since this is an equal sign, you could call this substitution if you wanted to. Since it is an entire side of the equation that we're replacing, I feel that it is more accurate to use transitive property. Since it's an equal sign, we're going to say of equality instead of congruence, but you could also say that it is substitution. Again, remember substitution does not work if it is a congruent symbol though. So that's kind of our introduction to proofs. I find that proofs get easier as we go. Sometimes these ones at the beginning with segment addition and angle addition, sometimes those are a little bit confusing. But we're going to try to practice, get the hang of these transitive properties, symmetric property, reflexive property of equality and of congruence, and all of our basic algebra properties and start seeing those in some proofs.